Hey. Welcome to Road to Web3, Week 6. I know we've had lots of you guys join us for the past 5 weeks or so, and you guys have learned a whole host of different things. So here at Alchemy, we're really excited to get you another week of challenges. This week, we're going to be working with a new platform. When I was, being onboarded to Web3, one of the things I learned to use as a really powerful tool was Scaffold-ETH. That's at least created by Austin Griffith, who's a great friend and also someone who's a really great builder. So today we're going to be learning how to build a staking dApp in the context of Scaffold-ETH. I know in the past couple of weeks we've gone through a lot of the building blocks, a lot of the sort of nitty-gritty tools that you'll use in Web3, hard hat from scratch, Solidity from scratch, front ends from scratch even. And that's really awesome, and I think those are really good building blocks. But one of the things that Scaffold-ETH is really able to do is it just gives you off-the-shelf sort of stack for rapid prototyping on Ethereum. If you don't want to think too much about setting up, your entire environment, you don't want to think too much about front ends, Scaffold-ETH is a great sort of opportunity to bridge those two worlds and then get a bunch of work done without really, spending too much time on one thing or another. I think it's really great for tinkering. We're going to be using Scaffold-ETH as sort of our base here. In this tutorial, we'll actually be using some of the base code from challenge number 1, a speedrun Ethereum. So if we take a look at speedrun Ethereum right here, this is actually something that Scaffold-ETH hosts, and it's a bunch of challenges that you can do and you can learn, and I think they're really awesome. So we're going to be basing our code actually off of challenge number 1, which is their decentralized staking app. So at a project, we'll be working on something a derivative of that, but we'll be using their base code as a starting point. If you're not too familiar with crypto staking, I think this is maybe the best opportunity to give you just a quick overview on what that means, what it's all about, and why that's important as a primitive to learn. Crypto staking really best summarized as the locking up and then depositing of crypto holdings into a smart contract. And oftentimes that smart contract is part of a DeFi protocol. Whenever you lock money up or you deposit it into, let's say, an account, one of the things that you may want, or maybe to incentivize that behavior, is to give you interest. So you receive extra on top of it, or you receive some sort of reward. And so that's really how staking works in the concept of crypto and really in traditional finance too. And I think, if you take a look at DeFi, if you're not really familiar with DeFi, crypto staking has really become one of the cornerstones of many decentralized finance protocols, and it just allows developers to create complex financial derivative products based on, a very simple concept of staking. And so today we're going to be thinking about, how does staking work, how we can do staking, and we're going to be doing, a really simple case that I think it certainly exists. There are real cases where this type of staking is available, but I think many sort of DeFi staking protocols tend to be more complicated. But that's okay. We're going to start with something simple and then move forward and work with something more complicated. So in terms of things we're going to be learning today, just want to go over the high overview. We're going to be learning to build with Scaffold-ETH, which is, I think, an awesome tool to hack together front ends and then craft Solidity backends, if we sort of call that a backend. We'll be learning about transferring ETH from wallets to smart contracts or vice versa, doing that in code. That's something we haven't really done too much of in the past. I think you might have touched on this in the Buy Me a Coffee sort of dApp. And then lastly, we'll be using Solidity modifiers. So that's something that I found to be really powerful and wanted to highlight this time around. I think, the general challenge itself won't be too complicated. You can follow along in code, or if not, you can, copy and paste that. At the very end, we'll have some nice challenges that I think will give you some extensions to think about. Number 1 about Scaffold-ETH, and then number 2 about staking. So I think that'll be really powerful. With that, we're just going to dive straight in. Not going to have too much fluff here. We're going to be downloading Scaffold-ETH. So I think just, another disclaimer real quick, Scaffold-ETH, I think, is really awesome at abstracting away environment setups and, front ends and Solidity setups and all of that. But that doesn't mean that we shouldn't be, really comfortable with the different primitives in Solidity. We should be more familiar with hard hat. We should be familiar with how React works outside of Scaffold-ETH. So we're not reliant on it. But for today, we're going to be learning how Scaffold-ETH works and how we can leverage it so we can learn more. But just as a heads up, not necessarily meant for production apps, but definitely something for hacking. So with that, we're going to be forking the base code repository from challenge 1 of speedrun with Ethereum, which we just saw previously. So let's go ahead and grab that git clone. So, for context, if you're following along here or you're new, I was on desktop. I have another sort of folder here, Scaffold-ETH demo. I'm going to plop this in. Awesome. We're going to just download everything. So cd challenge. Awesome. Nice. And then we're going to also do the git checkout since we want to switch to that branch. Let me just grab that real quick. Awesome. Switch new. And then we're going to yarn install. So I think this might take a second. It's downloading a bunch of stuff. But, downloading Scaffold-ETH is really that simple. All you need to do is spin up a new folder in your sort of working directory and just run a couple commands, and that's the power of Scaffold-ETH. You don't need to think about installation. You don't need to think about all the dependencies. It does it for you. So that's really awesome, really cool. And that's what I love about Scaffold-ETH. But yeah, so while we're letting that load, actually, we can go over, maybe some of the other speedrun Ethereum challenges that we have. So one of the ones I really enjoy, and I think like the most simple one, is just a simple NFT example. Lots of people like interested in how to make an NFT or something, and Scaffold-ETH starts with that. We'll be going through a similar sort of challenge as a decentralized staking app. It'll be slightly different. I think ours is maybe a little bit more complex or maybe a little more cool, but I think this is like a really good primitive as well. Some other contracts or sort of challenges that they have, token vendors. So for instance, I deposit one token, I get back another token. That's another really good primitive, similar to staking, but a little bit more of an extension. Dice games. So this is actually uses Chainlink Oracle for, I believe, randomness. That's sort of really cool. And I think we actually might have done something similar in a previous week. In terms of other stuff that you can see here, like check out all the other challenges. Definitely suggest that you take a look because I think there's lots to learn there. Okay, awesome. So I was just filling in the time. Looks like all our packages installed. Awesome, 30 seconds. I guess I have fast internet here. That's what I like to see. Great, we're going to move along. I'm not sure what your sort of preferred IDE is or maybe what type of developer environments you're familiar with. I'm going to be using Atom today just because I think it's nice and easy to use and really, really simple. So I actually have one that I filled out previously when I was writing this tutorial. So I'm going to spin up a new sort of project file. So let's go ahead and do that. We're going to go to desktop, Scaffold-ETH demo, challenge 1, and then we're going to open up our folder. Awesome. And so opening it up, do we need to do it? Hopefully it's already linted. You want to, based on your IDE, I think it's really helpful to have Solidity already downloaded and ready to go so you get that nice sort of UI. If you don't, heavily suggest that you do. But first things first, we're just going to notice sort of what our folder comes out of when we download Scaffold-ETH. We're just going to take a look right here at the folder file structure here. Really, the most important things we're going to be looking at here are going to be in our package. And in our case, we'll be looking at two types of files. So one, Solidity, and then the second, JavaScript, effectively. So hard hat, contracts, right? We have our two contracts here. Let's hit Staker. Awesome. Notice it already has all that nice coloring. We're ready to go already. And then our second sort of really important file that we'll look at today is going to be, is it in public? Source. There we go. It's in source, and it's going to be this app.jsx file. So these are going to be the two main files we'll be working off of, just for context. So hopefully, whatever IDE you have, just navigate to there, and we'll be ready to go. Awesome. Moving right along. So this is just talking about it. I'm just going to be following along from the guide that we have here. So hopefully that's a little easier for you guys. So a couple of things. We're going to need 3 separate terminals for the 3 following commands. So a little bit weird, but that's just how Scaffold-ETH works. So we're going to hit our terminal. I guess we'll just spin up a couple new ones. New terminal, new window, new window. Awesome. So it's going to be a little bit annoying, but we need a CD in. So CD desktop, CD Scaffold-ETH demo. Awesome. And then let me do the same on the other ones. Awesome. Desktop Scaffold-ETH demo. Awesome. And then we're going to follow the command. So I think the first one's going to be yarn start, yarn chain, yarn deploy. So yarn start. Oops. we might need to... I need to navigate in one more level deeper, I believe. Let's LS. Okay, there we go. Let me do that for all of them. Awesome. One more. Awesome. Okay, and then we can just do yarn start. Perfect. Yarn start. That brings us to our localhost port 3000. Pretty typical, nothing new. We need to do yarn chain. And then there we go. So we've started our local chain now. And then lastly, I believe yarn deploy. And let's see if that works. There we go. So it's loading, it's loading. We'll give it a little bit of time, and then we should have our UI pop up. Awesome. So it's loading, and there we see it. So this is sort of our base part of our sort of experience in Scaffold-ETH. I'm actually going to move my icon here so you can see that faucet since it's sort of important for us today. But nice. So this is our base UI. This is something that comes straight out of Scaffold-ETH. Nice and easy, nice clean UI. We're going to be thinking about, how Scaffold-ETH works first and just familiarize ourselves here. So that way, nothing comes as a shock. A couple big things, about Scaffold-ETH. So here we have our sort of default wallet. So notice we're on localhost right now, so we're not connected to Rinkeby, we're not connected to the mainnet, although you certainly could. You can hit connect and it'll connect to your MetaMask, but we won't do that for today. But what we want to do before we really, go in deep to Solidity or really get anything else done is we do need to get money from our local faucet. So, Scaffold-ETH makes this easy. You can grab funds from the faucet like that, and if you give it a second, it should update. There we go. So you get 0.01 ETH there. But for our purposes, you might want a little bit more. So just grab that address, click copy. Awesome. Address amount. Let's just do it in ETH. I like ETH, not USD. Nice and easy. There we go. 10.01. So that's just how the faucet works. So when you begin to test your contracts, you would need to hit the faucet. Nice. Awesome. So, we're going to have two tabs here, Staker UI and Debug Contracts. And I'm just going to explain the quick difference between those two. Staker UI, that's going to be the main UI that we're going to interact with here. So, if you were building a dApp, for instance, you wanted to make something for the public, Staker UI would be close to maybe what you're trying to do. I think really bare bones, of course, and you can jazz it up, you can make it nice, change the colors and all of that, but it's sort of our working tab. Debug contracts is actually a little bit more interesting. It's where you can interact with the contracts. So let's actually take a look at this. Let's take a look at this. So if we head over back to Atom, so notice that we actually have two contracts here. Example external contract, which is just an external contract we have. Staker contracts are really only one we care about today, but we have these two contracts. But if we look at debug contracts, we have Staker, right? And then we have example external contract. And if you take a look here, you see that it has two separate contract addresses. You can look at its balance, all of that. And then notice that, in our example external contract, we had this function complete. So we have a public function, payable, nice and simple. And if we come here, we actually see that complete also pops up and completed because this is, I believe, a public variable, public Boolean, nice. And notice that all of those key values that were originally in that contract get pushed to our front end. And so what this allows us to do is, I will admit it. I'm the first to admit that I'm a little bit lazy. I don't like using command line for a lot of my, I'd say hacking really more than anything. And I want to have a nice UI to be able to copy and paste in, my address, or I want to just be able to type in a value, like 100,000, whatever, 10,000 ETH and send it. And I want to be able to refresh and hit, did this variable change? And so Scaffold-ETH does this automatically as long as you configure it. Once you configure it, it will grab all the functions, all the public variables from your contract, and then push it to this nice auto-generated UI. So that's one of the superpowers of Scaffold-ETH, just nice, simple UIs that are automatically generated. And, you can do, if you'd like to interact on a command line level, you certainly can. But if you're more, used to UIs that are maybe more intuitive, just like this, more clicking, more copy and pasting, you also have this option. So that's what I like most about Scaffold-ETH. I think that's mostly it. Let me see if I missed anything from here. Yeah, so we talk about the difference between the Staker UI and the debug contracts, talk about the faucets, nice. Yeah. Okay, that sounds great. So we're gonna dive right into the Solidity, and we'll do like a combination of copy and pasting, copy, and then like also explanations. So if we actually look at our staker.sol right here, you'll notice that it has a bunch of comments here. And so if you are, interested in Scaffold-ETH, want to give that a shot, maybe get some of those challenges, knock some of those off, by all means, like these are comments relevant for that. In our case, we won't be following the challenge to a T, so I want to just delete them. We don't want to confuse ourselves here, so that's nice and simple. Awesome. And so let's sort of see what we have here. It's nice to understand what we start off with. So first things first, we have this sort of contract here. So this is referring to our example external contract, which is aptly named the example external contract. And then we're just setting that. We're just grabbing that contract address and then setting it in via our constructor. So our constructor is fairly simple, and notice it's pretty much missing everything else, which is, the beauty of what we're going to do today. And so with that, diving into Solidity, before that, we should think about, what are our project parameters? Like, what are we trying to build out with our smart contract code? What are we trying to write? What's our goal really for the staking app? So we have, I believe, 5 steps right here, and hopefully they convey what we're trying to do today. So I'm just going to read them off because I think that's the most simple. So for simplicity, we only expect a single user to interact with our staking app. So in real life, lots of users can stake, lots of users can be interacting with our smart contracts, but in this case, we're only going to have a single user. Number 2, we want to be able to deposit and withdraw from our staker contract. So whenever we deposit money, we want to be able to withdraw from it. Pretty simple, makes sense. Couple things here. So staking is a single use action. So I think staking and withdrawing, I should maybe, be more specific there. Meaning that, once we stake and withdraw, we can't do it again. So single use, not only single user, but single use. Withdrawal from the contract removes 2 things. So number 1, the principal balance, meaning what we put in, and then any accrued interest. So that way we just take it all. Great. Number 3, so that staker.sol contract has interest payout of 0.1. Let me see if I did that actually. Well, I think I said 0.1, maybe 0.01 ETH for every block that the deposited ETH is eligible for interest accruement. The exact number, not that important. But we want 0.1 or 0.01, whichever works, for every block that the ETH is eligible for interest accruement. So I'll explain what that means really in the context, with more context a little later on. Number 4, upon contract deployment, the staker contract should begin 2 timestamp counters. So we're going to have 2 of those counters. The first is going to be set to 2 minutes, and then the second to 4 minutes. And what that really does is give us a window. So we're just going to look through these bullet points because I think it's really important, a little bit complicated, but hopefully it'll be more clear by the end of this. So the 2-minute deadline, so the first counter that we began, dictates the period in which the staking user is able to deposit funds. So I think this is more useful between t equals 0 minutes and t equals 2 minutes, so staking user can deposit. So they can deposit after the 2 minutes, they cannot deposit. So this is like fairly standard where you have a staking dApp and you have a limited time where you can deposit money. Awesome. And then, to break down the rest of these, all the blocks that take place between the deposit of the funds to the 2-minute deadline are valid for interest accrual. So what does that mean? So, if you deposited money immediately at time equals 0, then you would have 2 minutes worth of blocks where you would be accruing interest. If you, deposited 1 block from the 2-minute timeline, you'd only get 1 block's worth of interest. So that's, fairly standard. Like the longer you deposit money in for, the more money you get. Makes sense. Some other parameters that hopefully elucidates number 4 here. After the 2-minute withdrawal deadline has passed, the staking user is able to withdraw the entire principal balance and the interest until the 4-minute deadline has passed. So that means after the 2 minutes, the first 2 minutes have passed, you have additional 2 minutes to withdraw money. So, in total you have 2 and then 2 minutes for this like total interaction. And then sort of the last condition here is that after the 2-minute window for withdrawals has passed. So after the total of 4 minutes has passed, the user is blocked from withdrawing their funds since they've timed out. So we have this concept of like, after a certain period, you're not able to withdraw your stake anymore. That's all that sort of functionality is stating. And then lastly, number 5, if a staking user has any funds left, so after that 4-minute period, if there's still money in, the staking person, forgot or just didn't want to take out their money, we can call sort of a last function to lock the funds in an external contract. And we're going to lock those in external external contract, not sol. So that sort of, it's the second contract that was already given to us for free by Scaffold-ETH. So please forgive me. This is a little bit complicated, a little bit convoluted. If you need to repeat this part, please do drag that, the bar on YouTube or Loom or wherever this is, drag it back and re-listen to it. It's a little convoluted, but I wanted to make this particular challenge a little bit more real life. I think real life staking dApps have a lot of similar primitives to what we have here. You have a limited time for deposits, a limited time for withdrawals. And I think, many dApps, especially now, are starting to disincentivize unproductive capital. So they don't want money that just sits around. They want people who are actively engaging with the protocol, either restaking or just somehow interacting with their money. And so I think it's rare that a lot of DeFi protocols would actually absorb money that's left over. But this does happen in some protocols, and so that's what we're going to sort of do today. So it's just a fun little mechanism. It's closer to real life. I wouldn't say it is necessarily a one-for-one, necessarily for a staking dApp in the real world. Awesome. So, project guidelines, hopefully that makes all sense. We understand what we're making today. It really is, a proof of concept on an interesting staking, mechanism, staking contract. Awesome. So with that, we're going to dive into the code. I'm getting a little thirsty. I'm going to take a drink, but we're going to start off with Solidity mappings. Awesome. So in our smart contract, we're going to need 2 types of mappings or 2 specific mappings to help us store some data. So the first, we're going to be using the concept of balances. And then the second, we're going to be looking at deposit timestamps. Really, we don't need the plural there. It's just timestamp. And what we're going to do for those 2 things is just map an address to effectively a number. In the first mapping, the balance, self-explanatory. We're just going to save how much money was deposited in. And that's, the balance of the user that was staked. And then the second deposit timestamp is just to save the particular block time where that particular transaction occurred. And so in this case, it's going to be deposits. And why do we want to know this? Why do we care about the deposit timestamp? Well, we'll see a little later on, but obviously, maybe you already know the answer to that. Okay, awesome. So let's go ahead and do that in our own contract. And I'm just going to go ahead and copy and paste since I'm a little bit lazy. Awesome. So let's just actually make this a little bit more clear by calling it mappings. Awesome. Nice. Try to keep things readable. Comment where possible. I think that's helpful. Just a good practice there. Okay, second thing we're going to look at here, public variables. So everything we're going to do today is going to be public. Maybe, in the future or when you're doing this in real life, you actually want some private variables. In our case, it doesn't matter. We actually in some ways want public variables because when variables are public, Scaffold-ETH will grab them and then display them. So for instance, you see this in completed, that's a public boolean, so it'll grab it, display in the UI. So we're going to do that just so that we can see it and make that nice and simple. So we have a total of 4 sort of variables that we're going to add here. First one is going to be that reward rate per block. So I guess it was 0.1 ether. So that's going to be for every block that, we have a valid deposit, we're going to give 0.1 ether. And so that's what we have here. Number 2, we're going to be looking at withdrawal deadline. So this is our 2-minute sort of initial period where someone can deposit money in. And so we're going to create that public variable. The second, or I guess third in this case, is the claim deadline. So that's where the 4-minute mark, once it hits that, then we can no longer withdraw anymore. And, we can lock that money away in a second contract. And then this last variable, I call it current block. So it's just a way for us to store the current block. Why is it there? it's useful for something that's like, I guess, specific to local host testing. We just want to be able to like increment blocks a little bit. Like we want to be able to update our contract. And so that's why we have it there. It's really just to to spend gas and move the blockchain along. Not really necessary, but I think a helpful variable there. So yeah, we'll take a look at this hint. I think that's pretty useful. So we use block.timestamp plus, 120 and then 240 seconds to create deadlines exactly 2 and then 4 minutes after our contract is initiated. So like total like, full transparency here, definitely a bit naive as a timing mechanism, since it depends on when we start the contract and sort of specifically when we deploy the contract, and that's when the timer starts. So, as an added point later on, if you're feeling bored, you have some time, can you think of a better way to implement this so that it's more generalizable, for instance? So, like, it doesn't start until deposits start, for instance, or some other mechanism. So, just an extension there, not urgent, but something that I think would be cool if you guys could think about. I think a good thing to understand, but not necessarily the most important for this particular tutorial. Awesome. So we're going to go ahead, copy and paste this, dump it into our contract as well. Let's just, awesome. Let's throw in some variables here. I guess comments. So variables. Nice. Awesome. Nice and simple. Hopefully not too complicated. Next thing we're going to do. So we're actually not going to really push events to our front end. That's something that I think like Scaffold-ETH allows you to do, and it's really nice, and it's nice and cool. You can see history of like, all your on-chain interactions. But to sort of maintain coding best practices, we're going to make sure we include events in our contract, but we're just not going to really deal with it in our front end per se. But let's go ahead and copy and paste it in. 1 second. Apologies. I had some Discord notifications. Let's go ahead and do that. So events. Oops. I guess not that important. Awesome. So we're going to have 3 events here. So stake. So that means like when we deposit money in, maybe want to fire an event. Second, if we receive money. So this is specifically when we top up our contract for interest. So in order for us to be able to pay out interest, we need to have some money already in. So that's what the receive function is for. And then lastly, execute. So that's actually the function we use to, I call it repatriate funds. So that's where we like move money from the staker contract to the example external contract. So we lock it away. So we want, maybe some events to let us know when something has happened there. Nice. And so with that, I think that's actually most of our sort of setup, I'd call it, before a constructor. So we have a couple key things here. Does that all make sense? It should be pretty clear. I think it makes sense why you want some of these variables and what they may be used for a little later. Nice. Awesome. So we're just going to look a little bit into our functions. And actually, I'm going to start off with 2 read-only time functions, if that makes any sense. Something that we stated earlier in the project parameters is that many different sort of staking dApp functionalities are really reliant on this concept of a time lock. And that enables or really prohibits certain actions based on particular points in time. So, in our case, once you hit 2 minutes, you can do some things. When you hit 4 minutes, that kills some functionality and then unlocks something else. So this concept of like a read-only time is helpful for determining that kind of behavior. So if you take a look at our 2 functions, they're actually very similar in design. Just a simple if-else statement, nothing too fancy. Conditional checks whether the current time is greater than or less than the deadlines dictated already in our public variables. So is it 2 minutes, 4 minutes? And then if it is greater than the prearranged deadline, then we know that, we've passed that deadline, and then we return 0. And so that's just a nice flag for us to know. And then if not, we want to return how much time is left. So just the deadline minus the current block snap. And so you get the difference. So maybe it's 3 minutes, maybe it's 1 minute, whatever it may be. That's what we'll return. So 2 simple, nice read-only time functions. Let's go ahead and actually dump those in as well. And, ooh, interesting. Some formatting funkiness. Let's see if it works. Okay. Yeah, nice. And so actually, let's redeploy the contract. And I might have actually forgotten how to do this. Let me I believe I wrote it in here. Yes, you want to yarn deploy reset to refresh your contracts effectively. So notice that we've just added a bunch of things in our contract, in our staker contract. So we want to, make our UI or we want to make our debug contracts be able to reflect this. So let's actually do this real quick. So where do we have our yarn deploy? So let's do that. Drop it in. Awesome. So it's just going to repush it effectively. There we go. Nice. And so let's refresh our front end. And if we do that, notice that we have a bunch of new, nice, cool little, just nice UI elements that came out from our contract here. And so let's actually just take a quick look at what we have here. So for instance, we have a couple interesting values that have popped up. So we have 16, I'm not going to read it, it's too long, but this is effectively I believe 4 minutes after our contract was last deployed, and then this is 2 minutes after a contract has been last deployed. So that's sort of our starting timestamp for certain windows of our period. And if we look here, well, we haven't touched our UI yet, so we won't see it. But effectively, if you wanted to test things, you can come in here, drop a balance. So let's say let's check the balance here. It's 0. Does this make sense? It does make sense because in Solidity, mappings that don't quite exist yet, they will just return 0. So, all you're doing is interacting with your contract that you deployed, and this UI makes it simple. Just wanted to show off that. Awesome. Slight deviation. We'll be back on track. So we talked about the read-only time functions. Nice. The next thing we're going to look at modifiers. So I think I may not be the best person at explaining modifiers, and I think there's lots of other use cases that I think modifiers are really powerful and enable. And so for something like that, I suggest looking at Solidity by example. I think just a really nice, cool, easy way to learn. But maybe why are modifiers important? Well, what they do effectively are the small pieces of code that run before or after a function is called. And modifiers have a bunch of different purposes, but I think what's most relevant to this particular project is just gating. So you can gate certain functions based on certain parameters. And so in our case, different parameters dictate, the stake, the withdrawal, and sort of repatriation of funds functionality. And so we're going to be using modifiers specifically for that purpose. But what are the 3 modifiers? So we're going to have 3. 2 of them are going to be similar. So the withdrawal deadline reached and the claim deadline reached are going to be quite similar. The other one is going to be a little bit different, so it's not completed. So that just gives us whether or not, the stake withdrawal happened already once. But let's take a little bit of a look into our modifier. It's quite similar, if I'm being honest, to our previous function, and it's really meant to be. Effectively, what we do here, so let's say withdraw deadline reached Boolean. So what we're going to do is it accepts, I guess, a Boolean parameter, and we check to ensure whether or not the respective deadlines are true or false, so that it doesn't match the Boolean effectively. And what we're doing here is just checking it. So it's like, if true, then require, we're just checking, has it been reached, has it not been reached, and we're just if-elsing to check for those statements. Notice that we are calling another function here, so withdraw time left. This is a function that we'll need to write later. And so that's just, actually, if I'm not mistaken, we've already written it. Yeah, so this is just referring to the read-only that we check for what time is left. So if there is any time remaining, it will return the time. If no time is remaining, it will return 0. And based on that, we will know exactly whether or not the period has been reached yet or the period has not been reached yet. So that's sort of what the modifiers right here, these 2 modifiers do. The last modifier, not completed, what does that do? It's a little bit more complicated, I will admit. Even though there's less lines of code, it is a little bit more funky in nature because it actually talks to our example external contract. So it's looking at our, bonus free contract that Scaffold-ETH gives to us, and it's this complete function. And what it does is just flips the switch, effectively, is the best way to describe it. So it checks whether or not it was completed, and that's really what it does. So it's simple in some ways, a little bit more complex than others. And those are our 3 modifiers. So let's go ahead and copy and paste those in. Let's put those in. Ooh. guess some formatting funkiness. No biggie. We'll figure it out. No biggie. Awesome. And actually, let me check my other one. I've sort of filled out one already. Just want to make sure I have it right. Yeah, so in our case, I guess modifier should go above the constructor. So we're going to do that here as well. So let me actually minimize. Sorry about that. My error. We should maybe dump the modifiers a little higher before the constructor. So let's go ahead and do that. Nice and simple. Awesome. So we have, modifiers down. We have the read-only time lock function, not really time lock, but understanding time, read-only time functions down. The other ones we want to do now are the key functionality that we have in our smart contract. So depositing and staking function, that's a key one. So let's think a little bit about it, implement it here. So we're going to use the modifiers that we created earlier, and we're going to be setting some of the Boolean parameters for those modifiers, and then we're going to take advantage of that in our stake function. So in this case, we're just going to call the function stake. For context, if you haven't been following along in the naming convention, do suggest that you do, because Scaffold-ETH looks for a particular contract or specific function name. So if you do end up changing the function name, like, it will work, but you will need to do other stuff in Scaffold-ETH. So suggest that you just generally follow the same the same function name, so that way we can follow along together. So we're going to be looking at the stake function. So notice it's a public, it's payable, and we're using the modifier with withdrawal deadline reached false, claim deadline reached false. So let's think about why this makes sense. Obviously, when we stake money, we don't want it to be in any other state. We want that the 2-minute deadline hasn't been reached yet. Because we only want people to be able to stake money between time equals 0 and time equals 2. So that's what it ensures us to do. And then I guess claim deadline reached is a little bit extraneous here, actually. We don't necessarily need it because there's no way for the claim deadline reached to be true if withdrawal deadline reached is false, I guess. But, just for redundancy, we're going to dump that in there too. And then, let's just take a quick look at the other 3 lines here. Balances message.sender is equal balances message.sender plus message.value. This is a pretty standard deposit sort of scheme for staking contracts, or really just any contract in general. So hopefully this is not the first time you've seen it. If it is, just a FYI, very common sort of pattern here, and that uses the mapping that we created earlier. And then what we're going to do here is also use another mapping that we created earlier, deposit timestamps, and it just sets this particular address, so the staking user's address, as the current timestamp, and we save that, and we'll use that later on, and then we're just going to emit that stake event that we talked about earlier for best practices. Nice. So, pretty simple, nothing too complicated, I think, in the staking contract so far. Let's go ahead and implement that. Nice and simple. Control S, never forget that. Withdrawal function. So, we've deposited the money. We want to be able to withdraw it. And we're going to be using the same modifiers that we created earlier to help us with this. So once again, public function. But this time we want withdrawal deadline reached to be true, meaning that 2 minutes has already passed. But we don't want the claim deadline reached to be true, because this would indicate that the 4-minute has already passed. So we want it to be greater than 2 minutes, but less than 4 minutes. So we have 2 modifiers here to help us with that. And then we also have not completed, so we just want to make sure that this whole process hasn't already been done. We don't want someone to be able to withdraw money multiple times. That makes sense. So we're going to dump in a require statement here just to check whether or not we've already withdrawn money as an additional thing, or maybe the user who's trying to withdraw money never had money there in the first place. So it's a nice check to have. We're going to just grab balances. So we're going to read that mapping that we stored earlier to get the base principal amount of money in the staking contract. And then here is going to be the reward calculation. So we're just going to, calculate really quickly how much money does this particular staking individual, how much are they owed? So why does that make sense? Or maybe what's going on here? Very simple. What we're doing is just calculating the current block time. So when the withdrawal happens, what is the current block time minus the block time when it was deposited, and then we're going to multiply by the reward rate per block. So I think that's 0.1. And so that's how much ETH per block a particular stake is owed, and then we're going to add that to individual balance. And so that's how much money that would need to be withdrawn if we were trying to withdraw both principal and interest accrual. And so that's why we have individual balance rewards, and that's what we're trying to withdraw. And then lastly, we're going to be effectively just transferring from the contract back to the staking user's wallet address. And so we're going to move that money over. And so notice that we're actually using message.sender.call because this is most, according at least to Solidity by example, this is the most correct way to transfer ETH. So we're just going to use that and sort of adhere to it. And so, this is sort of our withdrawal function in a nutshell. A little bit complicated, I will say, but I think it generally makes sense, hopefully. So we're going to just grab that, copy and paste it into our contract right underneath stake. Nice. I think, once again, some formatting funkiness, but that's okay. Nice. Awesome. So one of the sort of last functions that's really important for our particular contract is this execute repatriation function. What is this function? I think we talked a little bit about it earlier, but what it does is it moves the money from our staker.sol to the external contract. And so it locks it effectively. So, once the money's moved, you can't access it anymore. And so what we're going to do here, we use execute because that's what speedrunethereum.com they originally had. So the UI is already configured for it. So we're going to, call it execute. I think we can come up with a better name, but that's okay. It's a public function. We're going to be looking at claim deadline reached to be true. So that means we want the 4-minute period to have passed. And that's when we want to be able to lock money. And then also not completed, meaning this hasn't been done before, effectively. And so we're going to do that. And what we do here specifically is grab the contract balance. So that means whatever money is currently in the staker.sol, we're going to grab that. And then we're just going to send it. That's what we're doing here. And then we also flip the switch on the example external contract. So that's what we're doing here with this repatriation sort of a funds type function. So pretty simple, nothing too complicated. I think the most sort of weird part of this function is that we call something else on an external function. And so that's the beauty of Scaffold-ETH, makes it a little bit easier to sort of handle that just, within the contract itself. And so if you followed along so far, your staker.sol should look something like this. So I think we've done most of it. We just didn't implement, let's see, I didn't copy paste and execute yet. And then, oops, that's weird. Popped all the way up. We didn't copy that yet. And then also, there we go. And then what else did we not do? Oh, we also didn't implement kill time. So I guess those are things definitely we want to do, but we haven't done yet. I think the last thing I want to talk about, and we should definitely implement in our sort of tutorial here, is this receive function. So what receive does is just allows us to send money to this particular contract address. And why is that important? Well, we need to be able to top up our staking contract. So whenever you're staking money, there needs to be enough money there to pay out interest. And so as sort of a pseudo way of, a gimmicky way of doing this is we're just going to top up the contract when we start off with some extra ETH. So that way we can pay off the interest that we occur. So obviously not a real life scenario. So, we can ignore that part, but it's important here. And we can just dump this really in whenever we want a contract to be able to receive money. So external payable receive function. And so with that, let's actually grab the entire thing. Since I don't want to copy and paste each little part, we're going to dump it into here. So we're going to rename. We don't need to rename. We just need to copy and paste it. Awesome. And effectively, that's for Solidity. So let's just redeploy this. Great. And then if we refresh our debug contracts, awesome. We have all of these things ready to go. So effectively, we are ready from the Solidity side, and we are sort of ready to get, we could technically run this, but we're going to be nice and fancy. We're going to add some UI elements. So I won't talk too much about front end. I don't think I'm the best front end person. I think Vito, Albert have done a really great job of some front end stuff, but I think Scaffold-ETH takes care of a lot of this for us. So we're just going to dive in a little bit to explore our app.jsx file. So that way, if you are, privy to jazzing up your code, making it look nicer, you're empowered to do that. So looking at the app.jsx file, which is right here, let's just switch that around. If we look there at around, line 573. Ooh, that's 573, right around here. Notice that, we actually, what Scaffold-ETH does is we have a bunch of React components that are wrapped. So we have like the concept of the list, we have list of staking events. So, previously we talked about how we didn't want to deal with staking events. So for instance, if we didn't want that, let's look at the before and after. So in the Staker UI, we have this stake events sort of list where all the staking events would be pushed to this list here. If we didn't want to see that, we can just go ahead and grab this div, delete it. I believe, there we go. Didn't need to refresh. It does it itself, and it takes it out. So Scaffold-ETH makes it nice and easy to do that. We're going to be making changes that affect Staker UI. Obviously, if you didn't want debug contracts, you can remove that, but we'll leave it in. I think it's useful. Nice. So front end edits. Pretty much what we want to do is create something that looks like this. So we have the Staker contract, which is already here. Time left, we're going to change up. So we want like the claim period left. So the 4-minute deadline and then the 2-minute deadline right here. We also want a couple other sort of parameters that are not included here. So total staked, meaning like total available ETH in the contract. So that's how much you put in, how much was already put in to pay for interest earlier. And then the last is like the ETH locked in. I actually don't know if it's Staker contract or... Yeah, so this is the ETH locked. So we also want that. Awesome. So let's take a look at a couple of the code snippets that we'll be using here. One of the things that Scaffold-ETH does, as I already mentioned, is they have these like React components. So one of them is balance, actually. So if you look at some of the other code here, let's see if I can find one. So like balance right here. For instance, balance right here, all you're doing is passing in a variable, so Staker contract balance. And then balance is sort of React component, and you can just change the font size. It has some like certain parameters dictating in the background for the font type or like the font weight, what font is used. So what Scaffold-ETH does is take care of that in the background. All you have to do is really configure it with a couple low code sort of parameters. And so that's what we're able to do. And we take advantage of that in this particular APY per block. So so APY per block, we're going to dump that in effectively. We're going to dump that in where? Let's see. We would want to put that right underneath Staker contract, I believe. Nice. And I think let's try to rerun it. Let's see what happens. I think we might see a massive error because it's reading a variable that we don't have. So yeah. So, one of the things, there we go. You can see it. So it's saying reward rate per block not defined. And that makes sense actually, because this reward rate per block is not something that we have read out from our smart contract. So if we look at the final example, I think that should help us. And let's see. What was that? Let me grab that value. Oops. Reward rate per block. Nice. Oops. Maybe we want it here specifically. So what we want to do is actually grab this particular area, which I guess we can copy paste that later. We don't need to do it right now. But what it does is it reads our contract. It reads the Staker contract specifically, and then it looks for read rate per block, which was a variable that we set already. We actually set this right here, reward rate per block. And so what Scaffold-ETH does is grabs that value, makes it nice and simple, and then pushes it so that we can use it in our front end. So that's why it was yelling at us, is because it wasn't there. So if I go ahead and dump that in now, it should be happy, and we should be good to go. So let's just, oops. Should have grabbed it before I closed it. There we go. Ooh, that'll be a challenge. Sorry about that. there we go. Let's go ahead and dump that in, and if we run that, it should there we go. And so now we have that block ready to go. So that's something I think I might have left out of the tutorial, but whenever you're reading a new variable, you need to grab it. You need to read it. So make sure you do that. Nice. And so we're going to do that a few times here. We're going to do a similar thing for the deadline UI elements. So notice that we have the read functions here to read claim period left. And in that case, we are reading, well, the contract again. And then we're going to push that to our front end here as well. So that way we can see how much time is left for the 4-minute deadline and then 2-minute deadline. Nice. Some other stuff, I'm just going to briefly go over this. This video is getting a little bit long, so I don't want to take up too much more of your time. We're going to look at 2 other examples of front-end UIs. So I think specifically this would be the total available ETH in contract, and then the ETH locked. So I want to get your creative juices up and running. You don't necessarily need to follow it word for word, but I think it's just important that you tinker with it a little bit, change it up. Just make it generally look like that. Maybe a little bit of deleting, a little bit of adding. I won't say it right now because I think it's good for you guys to practice a little bit. So I'll leave it as an exercise there. And then the last thing that I will say is like freestyling on the UI. So let's say you wanted to, create something a little bit more snazzy. You wanted to create something a little bit more hip. And in our case, we actually have these dividers, so these lines between things. So one of the things Scaffold-ETH does is it exposes other React libraries or just components that you can use. In the background, Scaffold-ETH uses a lot of stuff from Ant Design. So if you head over to the components, you can see a lot of these like nice, UI elements, whether it's like field, like forms, buttons, like switches, whatever, icons. Scaffold-ETH sort of allows you to just import that. So make sure, if you wanted to use divider, you just need to add it to this list, which lives at the top of your app.jsx. And then you can go ahead, drop that in, and then you can use it. Just nice and easy way to do it. I'm going to be lazy and save a little bit of time. I'm just going to copy and paste this and dump it into our file here. So we have all of that nice UI ready to go. Awesome. And then if we hit refresh, there we go. So everything's pretty much set and right now. I just run a quick test to make sure that at least a few of the key pieces of our sort of contract is working as we expected. So what we're going to do right now, I just refreshed the contract. I noticed that we're actually, there's actually a cut in between these two scenes, and technically this is APY per block second, so we're actually giving out a payout per second in time. So it's actually a little bit more than I expected, which is okay. But what we're going to do is just refresh our contract and then test some functionality. So let's go ahead and do that right now. I'm just going to re-undeploy it once more. So we have the latest update. Nice. Okay. We do want to make sure we have as much. Okay, we have 2 minutes. Great. So let's go ahead and deposit some ETH into our staker contract. We'll do 10. Should be plenty. And then let's also make sure we top ourselves off with some ETH right here. So we're going to send ourselves 10. Nice. Awesome. So we've got about 1 minute and 30 seconds left right now. What we're going to do is go ahead and stake 0.5 Ether. So one thing to note actually right now is that, what we can do is kill time. Kill time just like helps us move the clock along in our sort of local host, our local sort of blockchain. So what we're going to do right now is just stake our 0.5 Ether. Awesome. So we've got about 1 minute left. And so with that 1 minute, we should be accruing interest. We should be getting that sweet, sweet interest. And in about 1 minute, we will check back to make sure that we can actually withdraw money. And we should have more than 10 because we put in 0.5. And for every second that our sort of staking is happening, we get 0.1 ETH. So yeah, FYI note here, it's actually APY per block, but by block seconds. So literally every second. So just want to be clear about that and not confuse anyone. Awesome. So we're just going to hit kill time. I think I talked about this earlier, but kill time just sort of moves time forward. Helps us refresh time effectively. So I think, since we have about 30 seconds here, I'm going to kill some time by introducing maybe something else that you could do. So if you don't want to hit kill time in our debug sort of contract mode, maybe one thing you could do is make a button here so that you can call it out here and just get rid of the debug contract section. I don't know, tons of different projects you can do. Let's hit it again. Let's see where we're at. We should be very close. So we have 1 second. Awesome. So what I'm going to do right now is hit withdrawal. So that transaction was sent. Awesome. And look at that. So we have 17.5 ETH now in our wallet, which makes sense. We had maybe about 60 seconds or so of transactions, or maybe a little over 60 seconds, and at 0.1 ETH per transaction, 0.1 ETH per second. That just comes out to about right. So that's what we like to see. Our contract seems to be working correctly, and that's really awesome. Okay, so let's just go all the way back down to our Road to Web3 sort of guidelines here. So I want to leave you guys with the challenge that we're going to be working on. So I'm going to sort of leave it off to you guys, and you guys will figure it out from here. I have a couple of sort of guidelines that I'd like you guys to explore and just sort of figure out a little bit between yourselves. So the first thing we want to do is update the interest mechanism in the staker.sol contract so that you receive a non-linear amount of ETH based on the block seconds between deposit and withdrawal. So I personally suggest maybe like a basic exponential function, but really any non-linear function would be great here. The second thing I'd like you guys to take a look at is to allow users to deposit any arbitrary amount of ETH into the smart contract, not just 0.1 ETH. So what I mean by that, right now I just say stake 0.5 ETH, but let's say I wanted to stake 1 ETH. How can we do that? So I want to maybe push you guys to explore that as well. And then the last thing here is, instead of using the vanilla example external contract, so Scaffold-ETH gives us that one for free right about here. It gives us that for free. I'd like you guys to implement a function that allows you to retrieve the ETH locked up in example sort of external contract and then redeposit it back into the staker contract. So what this would do effectively is allow you to retrieve that locked funds. So it's not locked forever. And I think maybe one way to do this is to whitelist a single address to be able to call this function, like to gate its usage. And then I'd also want you to be able to like remove any logic or maybe add some logic so that you'd be able to ping and pong back and forth from the ETH from staker.sol to example external contract.sol, and you can move money back and forth from those two sort of contracts. And so those are the sort of things I would like you to explore. One last thing to note, I don't want to confuse anyone here. I believe previously in the tutorial I was referring to a lot of my functions as APY per block. This is a little bit inaccurate. I do want to say it's actually APY per second. And I don't want to confuse anyone there. Slight misunderstanding when I was making this, but it is technically APY per second, not block, because I am using block.time or time, since I'm specifically using block.timestamp, which is the sort of second snapshot. But want to call that out. But that's okay. Let me know if you have any questions. Happy to help you guys get situated. But if that's it, then happy building. Happy week 6 of Road to Web 3. Happy to answer any questions, and peace.